Now here we have to find the incenter of a triangle ABC. So for incenter of a triangle ABC, we have a standard formula. We consider here A with the vertex suppose x1, y1, B with the vertex x2, y2, and C the vertex with x3, y3. Now opposite to vertex A, we take the length as small a. Opposite to vertex B, we take the length as small b. And opposite to vertex C, we take the length small c. And then the incenter is given by abscissa of the incenter Ix is ax1 plus bx2 plus cx3 by a plus b plus c, and ordinate is given by ay1 plus by2 plus cy3 by a plus b plus c. So this is the formula for finding incenter. Now according to the given question, here the vertex A is given by minus 36,7. Vertex B can be taken as 20,7, and vertex C can be taken as 0, minus 8. Now once we have got these points, we can find the length of the sides. For example, at first we find here the length of A. Now by using distance formula, we can say this is 20 minus 0 whole square plus 7 minus of minus 8 plus 8 square. So that will give us 25. Similarly, we can find B which is AC. So again, we apply here distance formula. So you can write here 0 minus of minus 36. So that will be plus 36 square plus we have minus 8 minus 7 whole square. So that will give us under root of 36 square plus 15 square, and which will give us 13. And lastly, C, that is the side AB, is given by under root of minus 36 minus 20 whole square plus 7 minus 7 whole square. So that is this. So we have got A, B, and C. Now we'll simply substitute in the formula and get the value of the incenter, coordinate of the incenter. So this we get as minus 36 into 25 plus 20 into 39 plus 56 into 0 whole divided by A plus B plus C. So 25 plus 39 plus 56, comma 25 into 7 plus 39 into 7 plus 56 into minus 8 whole divided by 25 plus 39 plus 56. Now this will give us 1, 0, which is the required center. Now, when you have to find the centroid of this triangle, it's very simple. We know x1 plus x2 plus x3 by 3. So centroid of the triangle ABC will be x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Now from that we can just substitute the value here because the points are given here. So you can see here minus 36 plus 20 plus 0 by 3, comma 7 plus 7 minus 8 by 3. So you get here centroid as minus 16 by 3, comma 6 by 3. So that gives us minus 16 by 3, comma 2. Find the incenter of the triangle whose vertices are, we take the points as A1, comma root 3, B0, comma 0, and C, which is 2, comma 0. So first of all, we plot this in the Cartesian plane. We plot these points in Cartesian plane, and we try to understand that whatever triangle we have got here. So this is y-axis, this is x-axis, this is the origin, this is y prime, and this is x prime. So this point origin is represented by B. So we take this point as B. A is 1, comma root 2. A point like here, 1, comma root 2. We have the point C, which is on the x-axis, 2, comma 0. Now, if we join this point and this point, we can understand that AB length will be 2 units because it is under root of 1 minus 0 square plus root 3 minus 0 square, so that is 2. BC length will be 2 units that we can understand directly only. And lastly, AC. Now, AC length, here we get 2 minus 1 whole square plus root 3 minus 0 whole square. So that is 2 units. Therefore, what we understand that it is an equilateral triangle. Therefore, triangle ABC is an equilateral triangle. Now, if it is an equilateral triangle, then we know centroid, incenter, circumcenter coincide. So from here we can find the centroid because centroid and incenter coincides in an equilateral. In an equilateral triangle. And here is an equilateral triangle. So here we can find the centroid as 1 plus 0 plus 2 by 3, comma 0 plus root 3 plus 0 by 3. This gives us 1, comma 1 by root 3, which is an equidistant. The incenter of the triangle whose sides are given by y equal to mod x and y equal to 1. So if we plot this in the Cartesian plane, we find this is y-axis, this is x-axis, origin, x prime, and y prime. Now this is the graph of mod x. So this is y equal to x when x greater than 0. This is y equal to minus 6 when x less than 0. We have another side which is along the line y equal to 1. So this is what is given and we have to find the incenter here. Now first of all, the angle between this line and this line is 90 degrees. The reason is this angle is pi by 4. This angle is 3 pi by 4. So obviously the angle between the lines is 90. So you can understand that this angle is 90. So it is a right angle triangle. Now if it is a right angle triangle, we can understand it is a symmetric right angle triangle across the symmetric above the y-axis. It is a symmetric triangle about y-axis. So So from here we can easily understand that in center should lie on this y-axis because it is a bisector. Y-axis here the bisector of the angle at the point O. It's the bisector of the angle at the point O. So the in center should lie on this y-axis. So if we imagine a circle, we can understand that in center is lying here, and we have to find the radius. So radius is this circle. This is the radius here. So this radius you can find very easily, and we have to find the in center. So for the abscissa, it will be 0. Now you have to find the ordinate. Abscissa is definitely 0 because it is lying on the y-axis. Now, how can we find the radius here? We know that in radius equal to triangle by S. Here, this point is 1, 1. Why 1, 1? Ordinate is 1 because it is the intersection of the line y equal to 1 and y equal to x. Since y is equal to x, that will be 1, 1. Similarly, this point will be minus 1, 1. The reason is the ordinate is 1 because it is lying on the line y equal to 1. And here it is given y equal to minus 6. Now, after we have got the vertices, we mark this as A, this as B. So, to get the radius here, if we take this point as D, then CD equal to in radius R. Now, in radius is given by triangle by S, where S is the same perimeter. Triangle, we can find the area of this triangle. Now, to get the area of the triangle, we need OA and OB. So OA equal to under root of 1 square plus 1 square, that is root 2. OB will be again root over of 1 square plus 1 square, is actually minus 1 minus 0 whole square, so ultimately 1 square. So this is giving us root 2. Lastly, this length that also you can find out because it's a right angle triangle. So AB square equal to OA square plus OB square equal 2 plus 2, and therefore AB length is equal to 2. So we have got AB, we have got OA, we have got OB. So here at first we find out semi-perimeter, that is half of OA plus OB plus AB. So that gives us 1 plus. Next we need the area of the triangle. It's a right angle triangle. We know OA, we know OB, so that we put the value here. So that will be half of root 2 into root pi s. S is root 2 plus 1. So this gives us 2 by 2, 1. So it is 1 by root 2 plus 1. So that is the in area, that this length is root 2 plus 1. Very simple. This length is root 2 plus 1, and this total length is 1 unit because this is y equal to 1 line. So here we can say that OD length is 1 unit. We write here OD length, we take here that OD length is equal to 1 unit. Now when OD is 1 unit, we have got CD length equal to 1 by root 2 plus 1, and therefore OC equal to 1 minus 1 by root 2 plus 1. That gives us root 2 by root 2 plus 1. And therefore required in center will be 0, comma, root 2 by root 2 plus 1, which is the required in center. So here vertices of the triangle are given us. We take as A 2 comma half. We take B, which is half comma minus 1, and we take C, which is 2 comma root 3 minus 1 by 2. So at first we'll plot this in the Cartesian plane, and we try to understand that what type of triangle is given here. This is x prime, This is y prime. This is also. So first point we have 2 comma minus up, so that will be the up point in the fourth quadrant. 2 comma minus. We take the point B, which is half comma minus, and we take the point C, which is 2 comma root 3 minus 1. 2 comma root 3 minus 1. So if we join these sides, we get a triangle. Now you can understand that here the axis of A and C is same. Axis of A and C is same. That means this angle should be 90. And we observe the ordinate of A and B is same. That means AB is parallel to x-axis. And since the axis of A and C is same, so AC should be parallel to y-axis. So that means angle CAB is 90. Since CAB is 90, so the orthocenter of the triangle ABC should be equal to A. So since abscissa of A and C is same, therefore AC is parallel to y-axis. Then we can say again ordinate of A and B is same. So AB should be parallel to x-axis. And therefore angle BAC equal to pi by 2. Hence vertex A is orthocenter of the triangle. Orthocenter of the triangle ABC. It is given A and B are the ends of the diameter of a circle. So we consider a circle here first, where we are given A and B as the end points of a diameter. A is given 3 comma minus 4 and B is given 7 comma 2. C is any point on the circumference of the circle. So this angle should be 90. This is semicircular. Angle ACB equal to pi by, as it is a semicircular angle. And this implies that triangle ABC is a right angle triangle. Now, if it is a right angle triangle, the midpoint of AB is the center of the circle. Therefore, midpoint of AB is the circumcenter. So we can find it very easily. X1 plus x2 by 2, comma y1 plus y2 by 2. Now this gives us 5 comma minus 1. So that is the required circumcenter of the triangle ABC. Now we know that orthocenter, which is denoted by H, that is orthocenter of a triangle, center, which is denoted by G, and circumcenter, which is denoted by O. Are always collinear, they lie in a straight line, except for the equilateral triangle where they coincide. And this is always the ratio 2:1, except for the equilateral triangle, because in equilateral triangle they coincide. Here we can say HG by GO is always 2:1. Now here the points are given in the given sum. It is given the orthocenter is having the coordinate -3, 5. Center is given as 3, 3. And circumcenter we don't know, we have to find that. So we take the point as alpha, beta. Alpha, beta. Now we can apply section formula to get alpha, beta. So from section formula, we can write that 3 equal to 2 alpha plus 1 into -3 by 2 plus 1. Now this one simplification gives us that 2 alpha equal to 9 plus 3, and therefore alpha equal to 6. And similarly, we can get here coordinate of G as 3. So 2 into beta plus 1 into 5 by 2 plus 1. Now this gives us that 2 beta equal to 9 minus 5, and therefore beta equal to 2. And therefore circumcenter is alpha, beta, which is 6, We have to find the distance between the orthocenter and the circumcenter of the triangle whose vertices are given by. We take A as 0, 0. We take B as 4, 0. And we take C as 0, 6. So we represent this in the Cartesian plane. Origin is represented by A 0, 0. 4, 0, so the point will lie on the x-axis, and 0, 6, so the point will lie on the y-axis. 0, 6, after is 0, the point is definitely lying on the y-axis. We have x and y. Now to form the triangle, we just join B and C. So by joining B and C, we can see that this is a right angle triangle. The triangle ABC is a right angle triangle. It's a right angle triangle. Now that means what? A will be the orthocenter. A represents orthocenter, because this is the point where the perpendiculars meet, and we need here circumcenter. Now circumcenter is the midpoint of the hypotenuse of right angle triangle. Circumcenter, midpoint of the line segment BC. So that gives us 4 plus 0 by 2, comma 0 plus 6 by 2, that is 2, 3. Now we have to find the distance between orthocenter and the circumcenter, that is the line joining A and M. Now M we can just apply the distance formula now. It is root under 2 minus 0 whole square plus 3 minus 0 whole square. So that is root over of 30. Change of axis or transformation of axis or transformation of axis. And first you try to understand what is the meaning of it. We take here a Cartesian plane y, x, x prime, y prime origin. And we shift this origin without changing, without the rotation of the axis. We just shift the origin without rotation of the axis. That is, we'll be shifting the axis parallel to themselves. So if we shift the axis parallel to themselves, we get new set of axes here, which we mark as capital Y and capital X. And their new origin we take as H, comma. Here we have shifted the axis parallel to themselves. You can see that X parallel to this and Y axis parallel to this line. So just we have shifted without any rotation. So this is what we have done. Now, with respect to the original Cartesian plane, we have a point here Px, y. Meaning of this Px, y is we drop a perpendicular here and we drop a perpendicular here. So after dropping the perpendicular, you can easily understand that this is the foot of the perpendicular A, this is the foot of the perpendicular A. Now this point is x, 0, and this point is 0, 1, such that this is x and this is y. So this is x which you have got, this is y which you have got, this is with respect to the original partition. Now with respect to the new coordinate system, we can see that here we have a perpendicular. So this will have a new coordinate capital X, capital Y. Now this will be our capital X and this is our capital Y. Now this point which we have taken as H, okay, the new coordinate of the origin, and we get this is H, this is K. So this is H, this is K. Now from this we can easily understand that what is our capital X, because this point if we take as some n and this one some n, then we can say that here OL is equal to small x, OM equal to small h. Here MN is parallel to this length. We can mark it as the point R. So here what we can say that O prime R equal to MN. Now O prime R is this length that is equal to MN. Now from this we can say that is MN equal to OL minus OM. Now OL is length x, OM is h. So what we get that MN equal to small x minus h. Now MN and O prime R is same thing. So what we can say that this is equal to O prime R. Now from this we can say that capital X equal to small x minus h. So this is the first conclusion we get, that if the origin is shifted to some point H, K without any rotation, when the axes have been transferred parallel to themselves, then the new abscissa will be old abscissa minus abscissa of the new origin. Now similarly, here if you, this point we have taken as M, so this we take as M prime because both cannot be M. So this is M prime. Now if this point is M prime, this point is N, we can see this length and this length is exactly same. We can mark this point as some S. So O prime S equal to NM. So here what we can say, O prime S equal to NM. Now NM we can find by OM prime minus OM. NM prime is OM prime minus OM. Now here OM prime is Y minus ON is K. Now O prime is what? Capital Y. So from here we get this relation that ordinate of the point, which is with the new Cartesian system, is equal to the ordinate of the original Cartesian system minus the ordinate of the origin. This is what we have got. So when the Cartesian planes is shifted parallel to themselves without any rotation, then this is the relation between the abscissa and ordinate of the new coordinate of the point and with the old coordinate of the point. So that is the given equation is here given equation is x squared plus xy plus minus 3y squared minus y plus 2 equal to 0. This is the given equation. Now, what this equation will get transferred to or will become when the origin is shifted to 1, 1. So, origin is shifted to O prime, which is 1, 1 without rotation of axis. That is without changing its direction. So this point 1, 1, you can take as h comma k. So here we take that px comma y with a coordinate of any point on the curve in original coordinate system. And after transformation or after transformation of axis, the coordinate of the point P is capital X comma capital Y. So we know that we have the relation small x equal to capital X plus H and small y equal to capital Y plus. Now here we can say that small x equals to capital X plus 1 and small y equal to capital Y plus 1. So this is what we have. Now if we just replace x comma y in the equation on replacing x comma y in the given equation by capital X plus 1 comma capital Y plus 1, we get capital X plus 1 whole square plus capital X plus 1 into capital Y plus 1 minus 3 capital Y plus 1 whole square minus capital Y plus 1 plus 2 equal to 0. We can write this one as capital X square plus twice capital X plus 1 plus capital XY plus capital X plus capital Y plus 1 minus 3y square minus 6y minus 3 minus y minus 1 plus 2 equal to 0. Now here what we observe, what we get here, 3x, xy and minus 5y. Minus 5y, minus y, minus 6y only. This y will get cancelled out. 1 get cancelled out. So this one cancelled out. So here we have 1, here we have 2. So 3 will get cancelled out. So ultimately we will be having capital X square minus 3y square plus capital XY plus capital 3x minus 6y equal to 0. That is the required equation. Here the given equation here given equation of curve is y square minus 4x plus 4y plus 8 equal to 0. Now we have to find that how does this equation changes when the origin is shifted to 1 comma minus 2. So origin is shifted to the point O prime h comma k we take, and that is according to the question it is 1 comma minus 2 without change of direction. Without change of direction. Now p x comma y the coordinate of any arbitrary point on the curve. To the point of any arbitrary point on the curve, which transforms to p prime capital X comma 1. So here we can say the small x equal to capital X plus h and small y equal to capital Y plus k. Now according to the given information, capital X plus 1 and small y equal to capital Y minus 2. Now we'll just replace x comma y by these values in the given equation. So we replace small x comma y by capital X plus 1 comma y minus 2 in the given equation. So it is capital Y minus 2 whole square minus 4 into capital X plus 1 plus 4 into capital Y minus 2 plus 8 equal to 0. We simplify this when we get capital Y square minus 4 into capital Y plus 4 minus 4x minus 4 plus 4y minus 8 plus 8 equal to 0. And we get here capital Y square equal to 4 into capital X. Now this is the equation which we are getting after the origin is shifted to the point 1 comma minus 2. It is given that coordinate of a point with respect to the original coordinate system was 4 comma 5, which gets transformed to p dash after origin is shifted to some point as minus 3 comma 9, and we have to find the point where the origin was shifted. So we consider here that let the origin be shifted. Let the origin be shifted at the point. Let the origin be shifted at the point O prime, which is h comma k, without changing the direction. Without changing the direction of coordinate axis. Now here we consider that the point P initial coordinate system as x comma y, which gets shifted to the point P prime capital X comma capital Y. The point is same, just for notation we have taken different P and P prime. So here we know the relation, that is small x equal to capital X plus h and small y equal to capital Y plus k. Now here small x is 4, capital X is minus 3 plus h. Now here small h is equal to 7 and Here y small y is 5, capital Y is 9 plus 3. So k equal to minus 4. So here origin has to be shifted to the point. Origin has to be shifted to the point 7 comma minus 4, so that the point P, which is 4 comma 5, changes to minus 3 comma 9. Rotation of axis. So we have yet a new topic as the rotation of axis. Now, what is this rotation of axis that we'll understand? At first, we have a Cartesian system. Here we have y, x, y, and x. So now this this Cartesian system be rotated by an angle of theta. So automatically x and y axis both will be rotated by the same angle. So this angle is theta. So when this axis is rotated, there will be a point P, which was initial point as x comma y with respect to the original point system, and after it has been rotated, the point P becomes capital X comma capital. Here we have to find that what is the relation. So here we take the help of complex number. Then it will be easy for us to understand. How? Initially, with respect to the original coordinate system, we have the point here because both are representing the same point. This one. Now, this point P, which can be represented as in complex number as small x, so small z, which we take as x plus I. Now, in the Euler form, this complex number z can be represented as mod z is OP length here, and into e to the power of I alpha. Here, e to the power of I alpha means this angle we are taking as alpha. So it is mod z here represents OP into e to the power of I alpha. Now, this we take as equation 1. Now, when it has been shifted to, when it is not shifted, when the axis has been rotated to any new coordinate system, which we take as capital X and capital Y, there we have new point P and we take that as Z dash. Now, Z dash will be mod of Z only because the distance remains the same, distance has not changed, only the angle will change. Because now only the angle will change because we have now the new angle which is beta. So we write here e to the power of I and mark it as equation 2. Now we just divide here z by z dash. So mod z will get cancelled out, or you can just substitute the value and then we can understand what will happen here. And here also mod z e to the power of I. So what we get e to the power of I alpha minus beta. E to the power of I alpha minus beta, that will be e to the power of I theta. Now from this we get that small z equal to capital Z dash e to the power of I theta. Now after that we can just substitute the value. Small z is x plus I1, small x plus small 1. Capital Z dash is capital X plus I into capital 1. E to the power of I theta, that will be cos theta plus I sin theta. Now from this, just we will get open the bracket. So what is it? Capital X cos theta minus capital Y sin theta. Sin minus plus capital Y cos theta. So we have got this as a real part and this as the imaginary part. Now we can equate the real part and the imaginary part on both sides. So if we equate the real part and the imaginary part on both sides, we get here that small x equal to capital X cos theta minus capital Y sin theta and small y equal to capital X sin theta plus capital Y cos theta. So this is what we have got as the coordinate after rotation, the relation which of. Now from this we could get capital X and capital Y directly also. How from this equation only? From this equation only we can rewrite this as this equation we mark as equation 3. Now we say that from equation 3 we can write here that z dash equal to z into e to the power of minus I. Now here we can just substitute the value capital X plus I into capital 1, small z x plus I1 e to the power of I theta, which will be cos theta minus I sin theta. Cos of minus theta cos theta only, but sin of minus theta minus sin theta. Now we can simplify this further. Capital X plus I into capital 1, and here if we multiply, this will be x cos theta plus y sin theta as the real part, and the imaginary part will get I into minus x sin theta plus y cos theta. Now on comparing the real part and imaginary part, we get capital X equal to x cos theta plus y sin theta. And on comparing the imaginary part, we get capital Y equal to minus x sin theta plus y cos theta. So this is what we have got as capital X and capital Y. It is given if the axis is turned through 45 degrees, find the transformed equation for the equation, that is 3x square plus 3y square plus 2x square plus 2. That is here basically it is said that there is an equation given. So given equation is it is 3x square plus 3y square plus twice xy equal to. Now the origin, the system of axis, the coordinate system of axis has been rotated through an angle of 45. Axis is rotated through an angle of 45. Angle of theta we write, that is 45. Now here in that case what we will do, in the given equation we just replace x by the new coordinate system. Suppose we had initially a point P, x comma y on the curve. Now this gets changed to some P which is capital X comma capital Y you can consider. Now here, so what is small x in terms of capital X? There is capital X cos theta minus capital Y sin theta. So now we know the value of theta. So from that we can just substitute the value of cos theta, cos 45 and sin 45, and we can write capital X minus capital Y. Similarly, small y, which is to be replaced in this equation, will get here as small y equal to capital X sin theta plus capital Y cos theta. So here we get 1 by root 2 into capital X plus capital Y. So we have got here small x, we have got here small y in terms of capital X, capital Y. Now we just substitute in the original equation. So here we have 3x square plus 3y square plus twice xy equal to 2. Now here 3x, x is here 1 by root 2 capital X minus capital Y whole square plus 3 into 1 by root 2 plus 2 into small x is here, capital X minus capital Y by root into capital X plus capital Y by root is equal to 3 by 2 into 2 times capital X square plus 2 times capital Y square plus capital X square minus capital Y square equal to, now we can multiply throughout by a 2 and we can write 6 into capital X square plus capital Y square plus 2 into capital X square minus capital Y square equal to, now from this we can say that is this will be 8x square plus 4y square equal to 4, which will be further simplified as twice x square plus y square equal to 1. Now this is the equation which we are getting after the axis has been rotated by an angle of 45 degrees. So here it is given that if the axis is rotated through an angle of pi by 4, then the given equation, which is a rectangular hyperbola, x square minus y square equal to a square, when the axes are rotated through an angle of theta, equal to 45 or pi by. So we consider here that there is a point P which is x comma y on the arbitrary point of the curve, which will change to P prime, and we take this one as capital X capital Y. Now we have to express small x in terms of capital X. So that is, we know the formula is capital X cos theta minus capital Y sin theta, and small y equal to here capital X sin theta plus capital Y cos theta. I know the value of theta, so if we substitute the value of theta, we get here 1 by root 2 capital X minus capital Y. And here we get small y equal to 1 by root 2 outside capital X plus capital Y. Now we substitute the value of small x and small y in this given equation. So on substituting x comma y by 1 by root 2 capital X minus capital Y, 1 by root 2 capital X plus capital Y in the original equation. We get here 1 by 2 capital X minus capital Y whole square minus 1 by 2 capital X plus capital Y whole square equal to a square. Now from this we can just take minus half common, and we can write here 4xy. Why 4xy? We can understand here x plus y whole square minus capital X minus capital Y whole square equal to a square. Now from this we can say it's minus half into 4 times xy equal to a square. So here we get xy equal to minus a square by 2. So very simple. And if we compare the given expression, which is given as lambda, so here we get lambda equal to minus a square by 2, which is the required answer. There is a given equation. We have the given equation of a curve. Given equation is 9x square minus 2 root 3 xy plus 7y square equal to 10. Now this has to be changed to a new equation. There's new equation that's after rotation. After rotation of axis through an angle of theta, it gets transformed to 3x square plus 5y square equal to 5. So this was the original equation, which is the original Cartesian coordinate system. When the axis got transformed, when the rotation of axis was there by some angle theta, we got the new equation. So we consider that Px comma y with the coordinate in the original equation, which got changed to capital X comma capital Y after the rotation. So we can say here that x equal to capital X cos theta minus capital Y sin theta and small y equal to small y, that is x sin theta plus capital Y cos theta. So we have got here y equal to x sin theta plus y cos theta. Now what we'll do, we'll just transform, we just substitute the value of this x and y in the original equation. Now from then what we'll find that how can I get to this one. So just we are replacing x comma y by capital X cos theta minus capital Y sin theta, comma capital X sin theta plus capital Y cos theta in 9x square minus 2 root 3xy plus 7y square equal to 10. So here we write 9 into x square, so that is x cos theta minus y sin theta whole square minus 2 root 3, small x is capital X cos theta minus capital Y sin theta and capital Y equal to x sin theta plus y cos theta plus 7y square, that is x sin theta plus y cos theta whole square equal to 10. Now if we simplify this one, we take here capital X square common, so we get 9 cos square theta minus 2 root 3 sin theta cos theta plus 7 sin square theta. Next we take x1, so twice x1 minus 9 sin theta cos theta minus root 3 cos square theta minus sin square, that's cos 2 theta we can write, plus 7 sin theta cos theta. With this we have y square plus 2 root 3 sin theta cos theta plus 7 cos square theta equal to 10. So this is what we have got. Now if we observe the equation where we are trying to transform, here we don't have any term containing xy. That means here the coefficient of xy should be 0. Otherwise we can never transform to this equation. So we say that the transformed equation is devoid of the term containing xy. The term containing xy. Therefore, coefficient of x1 should be equal to 0 in the above equation. So we get that this will imply minus sin theta cos theta minus root 3 cos 2 theta plus 7 sin theta cos theta should be equal to 0. Now if this is 0, what we understand that minus 9 sin theta cos theta plus sin theta cos 7 sin theta cos theta. So this will be minus 2 sin theta cos theta, that is we can write minus sin 2 theta. And so you can write as equal to root 3 cos 2 theta. Just I have transferred this to the right hand side. Now from this we can say that tan 2 theta equal to minus root 3, which will be tan of pi minus pi by 3. So from this we can say that 2 theta equal to 2 pi by 3, and therefore theta equal to pi by 3. So that means when the axis rotated by an angle of pi by 3, then we can understand that this equation will be transferred to this equation. Now we'll start learning few shortcuts which will be applying on coordinate geometry problems. The first one which we start with, that is, we consider that let x1 comma y1 and x2 comma y2 are the ends of the hypotenuse of a right angle triangle. Right angle isosceles triangle. Then the third vertex, is given by this shortcut x1 plus x2 plus minus y1 minus y2 whole by 2, which is the abscissa, and the ordinate is given by y1 plus y2 minus plus x1 minus x2 whole divided by 2. That is, if we have here right angle triangle such that the sides are of same length, and here we take the point A, x1 comma y1. Here we take the point B, which are the end points of the hypotenuse. Then the point C, which we take as x3 comma y3, is given by x2 given by this value and y2 is given by this value. It is plus minus. Now a question arises, why there are two possibilities? Because children, the C can be on this side of the line, C can be as well as on the other side of the line, and that is the reason we are having here two coordinates. So one is this point, one is this point. So both are possible. So that is the reason we are getting two values. Now we take the first example here based on this topic. Question says that there is a vertex A which is 7, 9, and there is a other vertex and the other ends of the hypotenuse is 3, minus 7 of a isosceles are the end points of the hypotenuse of an isosceles right angle triangle. Isosceles right angle triangle. Then the third vertex is given by x1 plus x2. So we consider this as x1, this as y1, this as x2, this as y2. So as per the formula, is 7 plus 3 plus minus 9 minus of minus 7. So it is ultimately plus 7 whole by 2, comma, that is the abscissa, and the ordinate will be given by 9 minus 7 minus plus 7 minus 3 by 2. So from this, we get 10 plus minus 16 by 2, comma, 2 minus plus 4 by 2. Now, when we take plus from here for the abscissa, for corresponding we will take minus for the ordinate. So we get here that this will give us 13 comma minus 1 as 1 point, and the other point which you get, that is minus 3 comma 3. When we are adding these two, that is 10 plus 2, that is 26, 26 by 2, 30. 2 minus 4, that is minus 2 by 2, that is minus 1. 10 minus 16, minus 6 by 2, that is giving us minus 3. 2 plus 4 by 2, that is giving us 6 by 2, that is 3. So here we get the two coordinates, the two possibilities are there. If we have two vertices of an equilateral triangle, with vertices are x1 comma y1 and x2 comma y2, then the third vertex is given by x1 plus x2 plus minus root 3 into y1 minus y2 whole divided by 2, this abscissa. And the ordinate is given by y1 plus y2 minus plus root 3 into x1 minus x2 by 2. So if we are given an equilateral triangle to the two vertices are given, the third vertex we can get as by this formula, which is quite similar to the previous shortcut. Just here we have a factor root 3. Now here also, if we see that here we have an equilateral triangle. Now we can see here that here we have a point vertex, here we have a vertex, here we have a vertex. Now here I take the point x1 y1, here I take the point x2 y2, the point A, which is the orient x3 y3. x3 represents this one, y3 represents this one. Now x3 has the two options, y3 also has two options. Why? One can be on this side of the line BC, and that can be on this side. So that is the reason we can have two coordinates. So just let us apply this shortcut in the next sum. Here we are given two vertices. One we take as B, which is 3, 4, and the other we take as C, which is minus 2, 3. So the third vertex is given by x1 plus x2, but here it is minus, so plus into minus, that will be into minus, plus minus under plus minus root 3 into 4 minus 3 whole divided by 2, comma, it is 4 plus 3 minus plus root 3 into 3 plus 2 whole divided by 2. So this is the point, other vertex we get. Now if you simplify, this is 1 plus minus root 3 by comma. Next 7 minus plus 5 root 3 by. That is, here we have two cases, 1 plus root 3 by 2, 7 minus 5 root 3 by 2, because when we take plus form for abscissa, minus for ordinate. And we have another option here, and it is 1 minus root 3 by 2 comma 7 plus 5 root 3 by 2. So these are the two vertices that are possible. 2 points, 2 corner, third vertex that is possible. In next one, we'll understand the formula for the ratio in which a point divides the line joining other points. We take here a point A, which is x1 comma y1. We take a point here B, which is x2 comma y2. Here is a point P that divides here the line joining A and B in some ratio lambda is to 1. Now, generally, by the application of section formula, we can say that x equal to lambda x2 plus x1 by lambda plus 1. And from this on, simplifying this, we get lambda x2 plus x1. And here we can find lambda, that is x minus x2 equal to x1 minus x. And we get lambda equal to x1 minus x by x minus x2. Now, similarly, we are not doing here for the ordinate because it will be the same thing. So you can say here, similarly, lambda equal to y1 minus y by y minus y2. So from this, we understand the ratio lambda is to 1 in which the point px comma y divide the line segment joining the points A x1 comma y1 and B x2 comma y2 is given by lambda by 1 equal to x1 minus x by x minus x2, or lambda by 1 equal to y1 minus y by y minus y2. So this is how we are getting the ratio. Now we just apply this in the next sum. That there is a line segment joining the points. Here we have a point, suppose A, which is 8, 9. We take here a point B, which is minus 7, 4. Just we are denoting, not by the exact plotting has not been done. Here we take the point P, which is 2, 7. And here we have the ratio lambda is to 1. So according to the shortcut we can have here, we can say this is x1, y1, this is xy, and this is x2, y2. So as per the formula which we have learned, x minus x1 by x2 minus x. So here 2 minus x1 by x2, which is minus 7 minus 6, that is 2. So this gives us minus 6 by minus 9, which is 2 by 3. Sometimes so you can think that we have learned the formula in this form. x1 minus x by x minus x2. Both are same, just a minus been taken common here. So then also you get the same result because x1 here is 8 minus x by x is 2 minus of minus 7. Ultimately 6 by 9, which is 2 by 3. If the points x1 plus t into x2 minus x1, comma, y1 plus t into y2 minus y1, divide the line joining, divide the line joining the points x1, y1 and x2, y2 internal, then find the range of t. Now, here we can apply the result very easily. First of all, which you have to understand that this division is internal division. Here, we take the point A, which is x1, y. We take the point here B, which is x2, comma, y. And here we take the point P, which we denote by x1 plus t into x2 minus x1, y1 plus t into y2 minus y1. So this is the point P which we get. Now we think here that it is divided in the ratio lambda is to 1. Since the division is internal, so here lambda must be greater than 0. So at first we find here lambda. We consider this whole thing as x and this whole ordinate as y. So according to the formula, lambda equal to x minus x1 by x2 minus x. So here x minus x1, that will give us t into x2 minus x1 by x2 minus x1 plus minus t into x2 minus x1. Now here we take t into x2 minus x1 whole divided by x2 minus x1 minus t into x2 minus x1. Now here we take t into x2 minus x1 by x2 minus x1 we take common into 1 minus 2. Since the 2 points are different, x2 minus x1 should be different and we cancel it out. And we're left with here minus common t by t minus 1. It is t by t minus 1. Now this lambda is greater than 0. So here this is greater than 0. Now this gives us t by t minus 1 less than 0. Now we take here a number. Now this is minus infinity, this is plus infinity. This is 0, this is 1. Now you apply Weber method, so plus, because here that is the highest critical point, we put plus, power 4, sign change. Minus, again sign will change because the power is 4. Hence we get the values of t should lie from 0 to 1. So here if we understand the sum is a very easy one. Just if we don't apply this shortcut here, it will be a bit time consuming. Now we come to point of trisection. The coordinates of the points of trisection of the line joining the points A x1 y1 and B x2 y2 are 2x1 plus x2 by 3, 2y1 plus y2 by 3, and x1 plus twice x2 by 3, y1 plus 2y2 by 3. It's a very simple formula, easy to remember also. And this can be obtained very easily if we apply the section formula. Then we can derive it very easily. This is A, x1, y1. This is the point B, which is x2, y2. Here we take the point of transition as P and Q. Now, here if we apply the section formula, because AP by BP is 1:2, AQ by BP is 2:1, we can get this result very easily. Now, let us take a sum. Let us see the application. We have to find point of trisection of the line segment AB, where A is given by 3, 4 and B is given by -7, 1. So here, if we apply the formula, so that is twice x1. So twice x1, that is 2 into 3 plus x2, that is -7 by 3, comma, twice y1. Twice y1 means here 2 into 4 plus y2 by 3. This is one point of intersection. And we have another one where we have x1, that is 3 plus 2 into -7 by 3, comma, we have the other one, that is y1. So y1 we take as 4 plus 2 into 1 by 3. That is, we are thinking this point, this appears as x1, this is y1, this is x2, this is y2. So we have 2 times x1 plus x2 plus, comma, 2 into y1 plus y2 by 3. Here we have, so x1 plus 2 into x2 by 3, y1 plus 2 into y2 by 3. Now, if we simplify this, we get -1 by 3, comma, 9 by 3. We have here 3, and this is 3 minus 14 minus 11 by 3. And lastly, we have 6 by 3, that is 2. Next one which we take here, it will be given the ratio in which the x-axis divides the line joining A x1, y1 and B x2, y2 is -y1 by y2, and the point of division is given by x1 y2 minus y1 x2 by y2 minus y1, 0. This is how when the x-axis is dividing, then this is the ratio and this is the point of division. Now similarly, we can here write the other one also, the ratio in which the y-axis divides the line joining A x1 y1 and B x2 y2 is minus x1 by x2, and the point of division is given by 0 comma x1 y2 minus y1 x2 by x1 minus x2. If you want to understand logically, then also it is a very simple thing. That is, here is the point A, which is x1 y1. Here is the point B, which is x2 y2. Now you consider that here the x-axis is dividing the line segment. So the point which will be dividing will have x comma something. This if we take lambda is to 1. Then just for finding this 0, we can say lambda y plus y1 by lambda plus 1. And from here we can easily understand that lambda equal to minus y1 by y2. Now once you have got lambda, you can find x by using section formula. When it is the y-axis, the absolute is 0, and we can get the corresponding result. There are 2 points here. One is A, which is 2 comma 5, and the point B, which is 1 comma 9, divided by the x-axis. So you can think it in this way, that here is the point A, which is 2 comma 5, and here is the point B, which is 1 comma 9. This is the x-axis dividing the line joining. Here is the point B. So this point will take us x comma 0. So automatically we know that ratio in which it is divided, that lambda is to 1, will be given by minus y1 by y. So here we can think that is our x1 is our y1. Here is x2, y2. So here we can just put the value 5 by 9. So what we say here, that x-axis divides the line segment AB external in the ratio 5:1. In the ratio 5:9. Now, similarly, we can find here the point of division also. So for point of division is the point of division, we get here y2 into x1 minus x2 into y1 by y2 minus y1 comma 0. That's the point of division. And we get here the point as 30 by 4 comma 0. Here there are 2 points are given. We take the first point as A, which is minus 4 comma 2. And the next point we take as B, which is 8 comma 3, is divided by y-axis. And we have to find the point of division also. So here is the point A, which is minus 4 comma 2. Here is the point B, which is 8 comma 3. Now this is we consider as the y-axis. So this point is R, which will be 0 comma something. We take as y only, and the ratio we take as lambda is to 1. So here lambda is given by minus x1 by x2. Now here this is x1, this is y1, this is x2, this is y2. So here we have minus of minus 4 by 8. So that gives us 1 by 2. So this shows that y-axis divides the line segment joining A and B internally in the ratio 1:2. Now we find the point of division also. Point of division, that will be 0, comma, we have here x2 into y1, so x2 8 into y1 minus y2 into x1 by x2 minus x1. So this gives us 0, comma, here it is 16, 16 plus 12, that is 28, 28 by 12. So here what we have, 28 by 12, so we get here 7 by 3 is the point of division. Now we move on to another very important shortcut here, that is if D, comma, E, comma, F are respective the midpoints of the sides of the triangle A, B, C, such that D is the midpoint of BC, E is the midpoint of CA, and F is the midpoint of AB. Then we can write A equal to F plus E minus D. We can write B equal to D plus F minus E. And lastly, C we can write E plus D minus F. Very simple thing to remember. If we just draw the diagram, we'll be able to understand that. It's a very simple thing. Here we have the point A, this is the point B, this is the point C, D is the midpoint of the side BC, E is the midpoint of CA, and F is the midpoint of AB. So how to remember? Very simple. When you are finding A, then it is A plus E minus D. Or how I remember, I always think about D first. That is, I say that D equal to what? Sum of the vertices here minus the opposite vertex which we have. So it is E plus F minus A. And you can see from here only you can get this one, just the interchange of A and. Similarly, when we are finding the point E, opposite to E, this is the line. So D plus F minus B. And lastly, F, opposite to F, we have this line. So E plus D minus C. So very easy to remember. So let us apply this in a sum. It will be more clear to us. We take the next sum where a triangle has been given. A, B, A, B, and C. And here we have the midpoints also. Here we have D, E, and A. So here D is given by 4, comma minus 1. E is given by 7, comma 9. And F is given by 4, comma 11. Now here we'll try to find D. Now for F's and ordinates, same rule will be followed. That is, when we are finding the vertex A, this will be what? E plus F minus D. So same concept. That is, here we can say that for the ordinate as well as the abscissa and ordinate. So we can say for the abscissa first that it will be 4 plus 7 minus 4, comma. It will be ordinate, so it will be 11 plus 9 minus of minus 1. This gives us 7, comma 20. Now we move on to now for the point B. B is at this point, so it will be F plus D minus. Now F plus D, so for the abscissa also you have to follow the same thing. So it is 4 plus 4. There is abscissa of F and D, 4 plus 4 minus abscissa of E, which is 7. Now for the ordinate of F and ordinate of D, so it is 11 plus of minus 1. So 11 plus of minus 1 minus 9. So this gives us 1, comma 1. Now lastly we come to the vertex C. For C also we have to follow the same procedure. That is, opposite to C we have this two, D plus E. Opposite to C we have this one, minus. So for C we have absorb D plus absorb E minus absorb F. Here we have ordinate of D plus ordinate of E minus ordinate of F. So we get here 7 minus 3. So this way we can get the 3 vertices very easily. Let D, E, and F are the midpoints of the sides of the triangle ABC. That is, D is the midpoint of BC length. E is the midpoint of CA length and side C. F is the midpoint of AB. Then the centroid of triangle ABC and triangle DEF coincide. That is, we do not need to find, suppose we know here the points of the points D, E, and F. D, E, and F. And we have to find the centroid of the triangle ABC. For that, we do not need to find ABC. We will do what? We will just find the centroid of the triangle DEF. Since the centroid of the triangle DEF and ABC coincide, so we are done. Very simple. Let A, B, and C are the vertices of a parallelogram. Of a parallelogram. A, B, C, D, taken in order. Fourth vertex is given A plus C minus B. That is the vertex D. It is very simple to understand. Very simple. We know in a parallelogram diagram is bisected. So we have here A, we have here B, we have here C, we have here D. So automatically understand that this midpoint is same for both of them. So from here on we can understand this is X, suppose this is x1, y1, this is x2, y2, this is x3, y3, this is x4, y4. So some of the abscess are here and some of the abscess are here will be same. But if we remember this one, we can do the calculation in a very simple way and convenient and in a very short time. So let us see one application here. We take here 4.3 points, which is given according to the question. That is A 3, 5, B minus 5, minus 4, C 7, 10. And we have to find the fourth vertex. So fourth vertex, just to keep in mind that it will be the sum of the of A plus B, just A plus C minus B. So A plus C minus B means that is for true for abscissa as well as the ordinate. So it is 5 plus 10 minus of minus 4. And hence we get this one just the addition of the three numbers here. So it is 15, 9. Area of quadrilateral whose vertices are given by x1, y1, x2, y2, x3, y3, and x4, y4 is 1 by 2, x1 minus x3, x2 minus x4, y1 minus y3, y2 minus y4. So here we can just apply this and we can get the value of the area of the quadrilateral, but it should be in the mode. So hence we get the result from here very quickly. We can just apply this concept in the sum that area of the quadrilateral whose vertices are given. So area of quadrilateral whose vertices are 1, 1, 3, 4, 5, minus 2, and 4, minus 7 is half of, just we can apply the formula now. We can think that this x1 is y1, x2 is y2, x3, y3, x4, y4. So x1 minus x3, and then we have x2 minus x4. Here y1 minus y3, so minus of minus 2 Next, y2 minus y, just the odd or even. Now we can simplify this one and we can write half of mod of minus 4 minus 1. Next we have here 3 and here we have 11. Now we take this with the mod for sure. Without mod, we cannot find the area. For MCQ, just we can keep that in mind that it should be under mod, and ultimately we get here half of minus 44 plus 3 within the mod definitely, and this gives us 41 by 2, the numerical value of the quadrant. So here we don't need to apply the two triangle concept. We can do the calculation very easily.